Good morning. Good morning, dear faculties. So, welcome to all. Welcome to the Pantech e-learning and welcome to the day 5, like last day of this particular FDP faculty development program in artificial intelligence with image processing. So, once again, welcome to all. So, sorry for this last class interruption. So, unexpectedly, we have to facing some power issue. So, that's why suddenly the live was ended. So, sorry for that. Today we can continue with that. So yesterday topic we have to cover. Then we have to go with that today's topics. Today I will show to you um, the age and gender reduction. So that is a OpenCV concept. I have to show age and gender reduction concept. Say like that YOLO object reduction. So YOLO we have to try. Image wise they have to detect the object. Same like a real time environment they have to detect the objects. Same like here the age and gender also real time camera we have to use and detect my real time humans age and gender wise, and image wise we also try to create the detect the age and gender. Okay, so that is so last part of the session we have to discuss about that. So now we can continue with that the pending one, right? So already was discussed yesterday we have to wind up with the activation function, right? So with the help of the relu and leaky relu is used for common hidden layer things, hidden layer activation keys. So already I told so how we can use the activation function where when it was used. So again I have to recall it. Um, yeah, so we have to try to see the types of activation, loss function, and optimizer, and how to select the each and everything. There are six kind of types: is the sigmoid, tanh, relu, leaky relu, softmax, and linear. So sigmoid and tanh is mostly used in a output layer. So output layer also having some kind of thing, because these two kind of activation keys is helps to decide what is our output, is a positive or negative. Since positive means they have to given same value. Negative means they have to mentioning the zeroth value. Like that way, the sigmoid and tanh both activation keys are used in a output layer. So relu layer is helps to relu and leaky relu it helps to identify in a hidden layer. That helps to reducing the analyzing the values in a hidden layers. So every hidden layers the data has been passed. Finally, they have to come in a output layer, right? So output layer just classify, identify. So what is this data? It is in a right data, classification data or regression data. What kind of data that only classify? Identify process only. They have to do in a output layer. So sigmoid and tanh is used in a output layer. Relu and leaky relu is used in a what was hidden layer. Softmax and linear in between the process, the flattened layer they have to assign, because softmax is designed for understanding this binary classification as well as multi-class classification, and linear is helps to understanding the regression values. So our values will comes like prices or numbers wise they have to comes like that, means the linear to help and identify the value of this particular data. Okay, so and also last class you was see the whiteboard, right? So I'll show the whiteboard. You was discussed something in that particular whiteboard. Okay, I think this one, right? Yeah, so now we can see, so this is the thing last class we was discussed in that particular session. So suddenly unexpected thing we have to enter the live. Yeah, okay, so just a minute. Okay, so last class we discussed. So here the ReLU, just zoom out this. So as a ReLU and leaky ReLUs are present in the hidden layer. The output layer, it was available in the sigmoid keys, sigmoid or tan H. So now we are using the cat and dog like classification way we have to use. So sigmoid keys helps in the output layer. So in between the process, one another layer will be add, that is a flattened layer. So flattened layer, here is a flattened layer. So in this place only the particular softmax will applied, softmax function. Okay, softmax. So mostly softmax and sigma both are do a same work. So sigma I already told, they have to decide the data, it is a 0 or 1s. So positive or negative. Positive means our expected value, our input value. So already input the cat and dog image is there, right? So they have to, dog image means they have to decide this is a 1. Cat image means it's a 0. Like that way they have to decide. So softmax is used for multi-class classification. We have to give a group of images. In that particular, inside the image, we have to detect the multiple objects. So there is a multi-class classification. So they have to give a softmax will applied in that particular position. So it is a flattened layer. Flattened layer. So when we are to using the multiple classes, we have to follow this flattened layer. Otherwise, the sigmoid is enough for us. Okay. So that's only. So now it's no needed. So you are getting confusions. So now I erase this. So when we have to try to see the multi-classes, we have to using the softmax. So now it's no needed. So when we have data as passed means finally it comes to the only two things. Two things only it's come. It's like this. So it is a 0 or 1s. Finally our output, the dog means dog or cat means cat. So like that way. So first we have to pass it our data into the here input one image. Inside the image one value is there. So one human or one animal, anything is there. So data is passing to the in each neuron wise, the data has to be stored individually. The every neurons is passing hidden layer one by one. So the randomly they have to pass it the values. So every hidden layers is moving to the one layer into the another layer. We can get it the loss value. So the ReLU to analyzing the loss value, and the loss value is considered as a loss function. The loss function to calculate the every neuron's loss value, and they have to hold it when we have to do the backward propagation. When you have to do the back propagation, so that process the loss functions to using this particular storing loss values to equalizing the data for our exact output. So that's why the loss values will be that. So we are expecting our out final we can get the loss values will be decreased, then only our model will properly trained. Otherwise we can't come to one decision it's trained or not. So like this way the every function will be there. So binary classification problem means we can using the ReLU or leaky ReLU in hidden layer and sigma function in the output layer. So multi-class classification means same layer will be followed in the hidden layer, but the output layer we can using the softmax. So just now I said binary means we are using the sigmoid. Multiple classes means we have to using the softmax. Regression means we have to use a linear activation. This is the difference between the others and each classification and regression wise. And optimizers, a gradient descent optimizer and the Adam optimizer. These two kind of optimizers it helps to make the processes the smoother way. So you know the optimizer, the comparatively the for an example comparatively the Android and the iPhone is a smooth processor is there because it is optimized. How many years we have to pass that we can use that particular iPhone means the same smoothness will be contained in that particular iPhone model. So that's why the iPhone is a very costliest phone. Same like that, here the optimization helps to make the every training process and working process as the smoothly they have to execute. They not get any glitches or any bugs. They avoid these kind of factors. They have to help to smoother way the training process will happen. There is two kind of things, common things, that is gradient descent and Adam optimizer. So the both are how it is work. So now I have to show you. Okay. So yeah, backward propagation we have to see, right? So once we have to see the particular slide, then only we can easily understand. You can see the backward propagation. So when you have to go the reverse process, yeah, the output will be there. So you're starting from the output and the last function and the optimizers. These two things are majorly work in a reverse process. So now we have to go into this part. So it's a reverse process, like backward propagation. Okay. So here the first step is output. So reverse here, right? So here the output is there. Starting from the output layer. So output layer starting from this, the last function will be considered. So next step is the last function. The last function will be applied. So last function means every layer contains the one value. So already I told this. So in between the every layers, some last values is there. So 0.8 and 0.7 like that way. So the last function to equalize, I mean sum of the every values. So every neuron's values. So it's 0.6 or 3. Oh, sorry. 0.3 or 0.5 or 1.2 like that way, and here also 0.81, 0.93, 0.87 like that way. This kind of values will be there. So the last function to equalize the every values, like equalize means sum of the every values, sum of loss. So then it's going to the next process, that is the optimizer, right? Yeah, next is going to the optimizer. So next process optimizer. The optimizer can only make the smoother way with the help of the any one model, that is Adam or what was that gradient. The Adam is as usual same process like our neural network passing data passing in neural network way. But gradient to make a decision which one is right. So which kind of way we have to go, we can make the proper output. For example, I have to show here. So now one hill is there, okay. Now one hill is there. So we have to stuck in any island or any middle of the sea means we are using the compass. The compass helps to analyzing the direction. Okay, where we have to go. Same like that, the gradient also working like this. So the gradient means they have to choose which kind of way we have to go. So sorry, I have to do one thing. So So is the hill means is a little more flat and surface. It is a very depth surface. So comparatively, which kind of way we have to choose, and going down to the safest way. So comparatively, is this way is a very uh, convenient way, right? So because it's a very flattened surface, we have to go with the walk. So it's comparatively we have to what was that? Go down in this safest way. So it is comparatively it is too much depth. So we have to make a decision. So gradient also working like this. So which kind of way we have to choose, we can make the proper output. So the gradient exact work like working process like this way, like this kind of format wise they have to execute. So this person is a one of the gradient model. The person have to choose which kind of way we have to choose. We have to going down to the safest way. You have to take a safest way. That is the important thing. The gradient model also working like this. Here we have to choose the gradient means. So gradient 1. So you have to choose for optimizer. So when the values are some of the values, they have to entering into this gradient layer. Here they have to choose. For an example, 1.5 and 0.7 and 1.0 and 0.10. So there is 4 kind of common values will be there. So for an example, only I said common neurons value will be there. So which one we have to choose? So for example, our image is a dog, we have to expect. Dog image we have to expect. So we can get the exact value nearest to 1. So which value is nearest to 1? Here in this 4 value comparatively, which one is the nearest to 1? Nearest to 1. So 1.0 is there as well as 1.5 is there. So comparatively it is nearest to 1. Alright. So 0.7 is having 3 digits. So we can make the 0.7. So which one is the most or very closest to 1? So 1.1 or 1.10 we can choose. Okay, not like that. Yeah, 1.3. 1.3 we have to choose. For an example, 1.303 is there. It is a very closest to 1. So the optimizer can give that neuron. So we can follow this neuron to our exact output. So they have to predict. It's a predictor value like that way. Predicted neuron. Because it is nearest to 1, so we are expecting output also 1. So the dog value, the dog image, we can represent to the 1. So that's why. So the optimizer working like this. So what is the next process? Then you have to go the new weight and new bias. Again they have to go to the input or output. Like again is going to the this process. Same forward propagation. So again entering to the input layer, and it's going to the for hidden layer. So this time based on this 1.03 values wise, they have to split. So every new values has to be split, and weight values also assigning followed by the 1.03. For an example only I said, so not is the exact value for every concept. Can you try to understand? So once we do the backward propagation, the output will be there. So output layer 2 going to the last function. The last function to sum of the sum of the every last values. Then is going to the optimizer, the gradient optimizer, to choose which one is fit for us. To choose the proper way to make a prediction or make a detect the image. Then the predicted neuron is going to the new weight and new bias values. They have to split it into the each and every neuron wise. Again they do the forward propagation. So forward process. So like this way, every neural network has to make a training. Okay. So I hope everyone understand. And so these are all the TensorFlow and Keras. It helps to make during the training process. So how to install this? So if people install Keras, people install TensorFlow. It's used to installing the packages or libraries. So types of neural networks. The most common 3 types is there: ANN, CNN, and RNN. So ANN is mostly used in text related prediction. So the price we have to set, right? So it's nearest to numbers because it is having less work. We have to converting the text into numbers. So that's why CNN is a little more complicated because it is an image writer. Image or video wise we have to use. Definitely we can follow the convolutional neural network. It is having the multiple layers. So that's why recurrent helps to the audio kind of data we have to use. So each neural network having a different unique style, a unique thing is there. So we can follow that. First one is the artificial neural network. So the process as usual. First we have to installing the Keras model, model and the layers everything. Then we have to create the model sequential, and we can follow it by the one by one layer. So say ANN, right? So add the dense layer. So single layer is enough for that. Already is told. So everything is have a single layer, and yeah. So dense layer is a single unit, 64 units, 64 neurons we have to pass, and a ReLU activation key and input dimension we have to pass, and next layer they have to apply the ReLU function. Then they have to go into the output value. Output activation. And activation is a softmax. Here we are using the any multiple classes. So that's why we have to using the softmax function. And the compiler we are using the Adam. So here they are using the Adam. So Adam's a as usual process. They make the text prediction. So that's why. And train the model. So model dot fit our input and output training. Number of epochs is a 10 and a batch size is a 32. Finally, they validate the model. We can get the proper output. This is the ANS one. And next one is a convolutional. So our image one. So you can see it's the best example for CNN prediction. Sorry. So here the input is there. So input is a kernel. So I already told that one image will they have to choose in the one particular place. Every inches they have to choose like this. So the kernel that's mentioned like a kernel. I told like a dimension, right? So dimension kernel both are same. So we can mention like a kernel. So it's the one of the kernel. And the convolutional plus ReLU. So every layer. So you can see these are all the hidden layers. In this layers the multiple joined layers also there. So you can see the convolutional plus ReLU. So multiple layers is there. The pooling layer to interconnect within every layer. The pooling helps to connect the every layers to pass it our data. That's why the pooling will be represented here. So ReLU only we can use in the every places because it helps to make their linear unit. So that's why. And next one is a flattened layer. So this is a flattened layer. Here the every multiple dimensions to comes in the single dimension. So here the 0.7, 0.2, 0.3 like that way the values will be assigned in this flattened layer. So apart from the flattened layer, the fully connected layer will be there. So the softmax activation. So here the particular output layer will be decide which is our exact output. So horse, zebra, dog, because it is look like multiple animals. Because more or less the zebra and horse both are look like a same. The horse is a plain plain appearance. The zebra was an the line appearance, right? That is the difference between the both. That's why they have to recognize the values like I say it is a horse or zebra or dog. Multiple classes they have to give. So based on the exact input value wise, we have to choose the right output. So this is our zebra is a right output. So here the maximum pooling layer will be applied. So here the 0.7 is the which values contains the more highest number, that is our exact output. Here 0.7 is the highest number. You can see the 0.7 that the name is a zebra. So we know what is our input. So zebra is our input. So the 0.7 is mentioning the zebra animal. So that is our output. Automatically the model can choosing the highest value of the neurons count or neurons value. So like this way everything will be CNN will be working. So CNN use a unique architecture with the convolutional layers that allows them to learn the local patterns and the features from the input data, and the pooling layers that reduce the spatial dimensionality of the features. This makes the CNNs well suited for tasks such as image classification, object detection, and image segmentation. So everything will be working like this because everything has to be in multi-classes also there. So the object detection we can we can choose using the multiple classes, multiple objects we have to detect. So majorly the softmax will be applied in that particular things. So this is the coding part of CNN. So keras.model sequential layers. So convolutional 2D, maximum pooling 2D, flatten and dense. This much layers is needed for image classification. So sequential model we have to create, and convolution 2D, and the based on the neurons count, and then kernel size, and activation key, and then maximum pooling. So every convolution layer, after that maximum pooling layer will be that. So check it what is the exact feature they have to extracted from this particular layer. So each and every layer they have to pass. We can come with a final compiler. So that is optimizer. The optimizer helps to make as a softest way they have to execution process. Then going to the fit process. That means the training process. Input or output. X train is input, Y train is output training. 10 epochs we have to choose, and 32 batch size we have to fix. Finally, we can make the prediction. That is our X test output. So recurrent neural network, that is RNN is a type of artificial neural network that is designed to process the sequential data such as time series, audio, signal, and the NLP and natural language. Like this kind of types they have to use. RNN has to be used. So unlike feed-forward neural network, RNN have a feedback loop that allows information to flow from the previous state to the current state, making them well suited for modeling sequences. RNN can be trained using the back propagation through the time algorithm, and variants such as the long short-term memory, and the network can get at the recurrent units. So GRU and LSTM, this kind of package, they mostly RNN can be followed. So this is the architecture of RNN. So sequential and embedding the values, and the LSTM we have to follow the package of the execution, and adding the layers. So same like a sigmoid layer. So which kind of voice is there, which kind of audio is there, like that way. And compiling the model, same like as Adam, the binary cross entropy, because it's a binary value. So metrics we have to follow by the accuracy wise, and we have to fit the process, the input training, output training. 10 epochs we have to choose, and the batch size 32 is a normalization, and the validation data for X test and Y test wise. Finally, they make a prediction as the model wise. So the epoch count is not a fixed one. Once we can increasing the epochs, we can get a better accuracy of our data. So that's why we have to choosing this epochs value. Okay, it comes later this part. So now this is the deep learning concept, how it is work layer wise, and how they make the training process, and everything you can understand, I hope. So next one, we have to go with that GAN model. So last class I have to say it, right? The GAN model. What is GAN? That is Generative AI concept 1. Because it is generating the values with the image. That's why I have to choose. So generative AI is a type of artificial intelligence that uses algorithms and the neural networks to create the new content from the existing data. So generative AI learns the patterns from training data and generate the new or unique outputs with the same statistical properties. So it can produce the various type of content, including text, image, audio, and synthetic data. Everything they have to create. That is the generative AI concept. And what are the major models are there in generative AI? So GAN, image generation and deepfake; VAE, latent representation and anomaly detection; and transformers, they have to language generation model. So the GAN is mostly focusing on to create the new image, and they have to identify it is a real or fake. Like that way they have to work. And VAE is working like a reconstructing the one particular thing, a particular image or data, whatever. So transformers is as usual language generation. So as usual we know the language generation or code generation, this everything comes under the transformers. Okay, now we have discussed about the GAN only, and reconstruct an image, it is no need for us. So just like that we have to see. If we have a time, we can see the VAE also. So GAN is a generative adversarial network. That is the GAN model. So mostly they have it have a two key models, that is generator and discriminator. First thing, they have to generate the new content. Then the discriminator has to be decide it is a right or wrong, like that, a real or fake, like that way they have to decide. So where it is help means applications of this art, deepfake, image synthesis and everything. It is a real art or fake art, like that way. And deep fakes are means the morphing, face swap, like that way they have to happening. Some kind of incidents also there, right? And image synthesis, everything will becomes under the real or fake. Like that way we have to see the particular image. The GAN model architecture involved two submodels, that was generative model and generate the new examples. Discriminator model for classifying the whether generated example are real or fake from domain are generated by the generated model. Real means already existed data. Fake means the generator or they are thinking one perspective wise, they have to generate the own idea wise. So you will see the example of GAN model, that is policeman versus thief. Like that way we have to see the example. Here the policeman is a discriminator, thief is a generator. So next one, their major concept is the thief will create the new or fake money. The discriminator has to be decide it is a real or fake. So generated major motto, they have to create the fake money like look like as a real one. That is their motto. And discriminator has to be check it is a right real or fake. So first they have to generate the empty plain paper. The discriminator had avoid it is a fake. They are ignoring or make a decision it is a fake one. Then they have to do the multiple cartoonized money they have to generate. The discriminator like do like that is also fake. Then the generator to create the look like a real money. So discriminator will decide it is a true because it is look like a same. They have to copying the real money to generate the new one. So one movie also, the familiar movie, the Farzi, the movie series is there. In that particular movie, they both friends, hero and their friend is creating the fake money and do it. I mean, they have to do it in our real uses. So like this example for this. Next one is a variation autoencoder. So that is a VAE. So we will comes later. Now we can see the example for GAN model. So I already showed that on coding. So now I give an example or explanation about that. Yeah, here. Okay. So here in this based on this coding we have to choose the GPU runtime. We have a hardware accelerator because it is a too much data is have and we have to convert the digit into the image wise. So that's why we need a GPU runtime. It most helps to make a earliest way the particular execution will be there. So we have to connect as usual. So yeah, so now we can see here we don't have any data. So we can get the data from our transformer model. We have to initialize the transformer, then from the transformer we have to create the data set and collect the data set, then we have to train. Finally we have to create the one log file. Based on the log file wise how much fake data, how much real data is there, we can see the the result in a one tensor board way or dashboard way. Okay, so now we can see before the execution there is no data in there. So we have to execute one by one. First I import the libraries, that is pandas as usual preprocessing library. NumPy helps to the numerical Python. They have to executing the numerical values, and matplotlib to create the plotting, I mean the diagram way they have to help to create. Torch and torch vision helps to the understanding the data and execution process for training. And the torch vision from the torch vision we have to create the transformer module, and utils of the data loader and summary writer, everything is needed for our tensor board. So we have to execution the data result in one board way. So that's why we have to need the tensor board summary writer. So once I execute in these libraries, so the installation everything is a common. Pip installs the common syntax for executing the every libraries. Okay, so you can follow this also in everywhere. So in Python you have to install means you can use the pip. Yeah, now it's executed. Then I have to go with that data collection. So transform of the compose. So here using the transformers model I have to choosing the data set. So transform dot compose of the transformers to tensor board, and normalized value is a 0.5 because every data will be there in a same equalization value. So that is a 0.5, and data sets we have to create to the torch vision dot dataset dot mnist digit generation. So we don't have to denote the digit, just like that we have to give a mnist dataset and the root of the dataset URL like this. You have to create here, the file has to be created, and transformer model we have to use, and the download we have to download the file also is a true, and the train the file also is a true. So now I run this, you can see. So now the transformer model will be executed and the data will be collected here one by one. So you can see the dataset will be there, the dataset folder will be there. Before that it is not there, just now it's executed. You can see the mnist inside the raw data will be there. So using this raw data we have to train this and execute to classify the real and fake images individually. If I click this, we can see the download option. Okay, download option is that there. Okay. So now we can go with the next one. So data set dot class to index. So what are the numbers present in this data set? So 0, 1, 0 to 9. So 0th number is mentioned like a text as a 0 and the number as a 0. Like that way they have to mentioning 1, 2, 3, like that way they have to execute. Then next one, batch size. We have to decide the batch size 32. That is a common and a default thing. We have to execute the every image related thing. 32 or 64. That is the bit range of the our system wise. 32 bit and 64 bit, like that way we have to follow in 32. And loader for data loader to the data set, and a batch size and the shuffle of this. Shuffle means randomly the images will be there. So batch 32 I have to run this. The data loader, everything will be loading into this particular variable of data loader. And plt.figure, here we have to execute in the digit one by one. So randomly the number will be there. So figure means they have to adjust in the size of the picture, and plt.imshow this execution already we know is related to our OpenCV. So imshow is executing the image. Next is executing the iter tool wise. Like iter means they have to executing one by one. So randomly one image will be executed. That is iteration. The loader means the every dataset will be loading into the loader model, and the 0 will be execution starting to 0 and ending also 0. Not like not like that means here you can see the class will be there in a 0 number and a 0. That's why I have to mention it here. And the per mode 1 to still 0. Starting to 1 and into the 2 dimension and the 0th index. And color map is a blue RC. It is a not a fixed one. We have to change, means we have to change the color map. So once I run this, randomly the number will be there. Now it's a 5. Yeah. So next once again I run this cell. Again 0 is there. Randomly the number will be there. So every time we have to run this cell, the random image will be there. So here we have to change it that if you do any mistake in this one, you can see the multiple color map types, like varieties. So like blues not there, so you can using they have to suggest to us values are followed as accent ray, sorry, accent r, blues r, brbg r, bugn r, bpu, like that. There's these kind of varieties. Anyone we have to choose and you execute. Now we're using the set 1. Now I erase this and using this set 1. That is one of the type of color map. Okay, it is not there. Oh, okay, it is a capital S. Oh, sorry. Now set 1 is like this. So set 2 also there. Set 1 R is there. You can follow the set 2. And set 3 is there. Set 3 R is there. So whatever we need we have to use. That is a reverse one, I think. And the gray also there. So gray is a black and white, like that way they have to execute. Okay. So you can give any mistakes, you can see the varieties, whatever you choose, you have to execute. Then we have to go with that CUDA model. That is, our model is a CPU format or GPU format. Just now we have to change it the model, right? T4. So you have to execute that. Device is a CUDA or GPU or CPU. So device equal to CUDA means they have to execute CUDA. If it is not else CPU means they have to execute CPU. Check availability of our runtime, like hardware. Once I check the device, you can see that is a CUDA. Now we are in the GPU format. Then we have to create the values, generated model, discriminator model, everything. That discriminator model said, first we have to train the discriminator model, because they have to decide it is a true or real or fake. That's why. Import the touch neural network, and the class we have to create the discriminator. Inside the class we have to create the multiple two different functions. Init function we have to do the training process. The forward function is move on to the next layer, like or as next process. Randomly self in features wise they have to execute it is a parent function, it is a support function, that means child function. So they have to make a decision, they have to initializing the process. That's why we have to choosing the two different init function. And self dot disk is equal to neural network dot sequential. So sequential model we have to initiate the neural network or linear leaky relu and followed by the linear one. We can use in the sigmoid. Finally they have to positive or negative. That's why we have to choose the sigmoid layer, sigmoid key for activation. Dev forward. So then once it is done means they have to go into the forward process. Self dot the forward discriminator, that is a disk. Then we have to use the generator. The generator motto, they have to train the new data, like create the new data. So generator init same like that. Init is a parent function and it's a child function. They have to make a decision, they have to execution. Sequential is to execute in the dimension of generator, and 256 start from the 256, ending also 256 they have to execute. This process also done, they have to move into the next one. So number of the dimension is a 64 dimension we have to use, and image dimension is split into the like this 28 cross 28 cross 1. Like that way we have to split it to these image dimension. And discriminator is discriminator is a image dimension wise. They have to analyze the device hardware unit wise. Discriminator generator both are executed. Then we have to fix the noise values of our image. So noise means some kind of dotted will present in our image. So that is the noise value. And the criterion of neural network is binary cross entropy loss. Binary cross entropy. That is a BCE means binary cross entropy. Because it is a real or fake, like that way we have to classify that. That's why. And optimizer as a discriminator, optimizer of generator. We have both are we are using the Adam. Disk dot parameters of linear rate is a 3 power 4 and learning rate is a 3 to 4. Here the learning rate both discriminated and generated are both the learning rate is having 3 to 4 value will be there. For percentage they have to make a proper prediction, like that way we have to represent. Epochs is a 10 epochs, just like that, because it take too much time, that's why we fixing the 10 epochs. And the writer and the real, so fake or real wise they have to create the tensor. The summary rate we have to execute based on the values or images wise, they have to assigning the image in a tensor board. So like that way we have to create the writer fake, writer real. Individually we have to create a summary writers, steps 0 to still number of epochs wise. So each epoch is contains how much thing is there. We have to create so already we see the output. So again we have to run this, we will see that. For epoch in a range of the epochs. So starting from the first epoch to how much epoch is there, they have to execute one by one. Still it is execution, completed, the loop will be repeatedly do that. Starting from the real one to enumerate the loader for this, and the real image we to view negative to still positive. That means starting from the -1, that is sigmoid value, right? Negative value to still the existing value. To our device wise, the noise value randomly assign it here, and the fake we generated the noise. First pass we have to train the discriminator. So discriminator real and wise, they have to execute in the view process starting from the -1, and the discriminator fake also starting from the -1. So criterion of this, it is a discriminator real and a torch once dot like means the real image we have to generate. How much of the real image is there, we have to generate based on the values wise. And the last discrimination fake is a criterion of this, we have to fix it here. The every values will be stored here. That is the last discriminator of real and fake wise. Finally, both values are added, addition by the both values divided by the 2. That is the final thing. And the last discriminator backward progress, we have to do the retain graph. We have to create the one graph value based on which we have to come to an understanding. And output will be executed the discriminator wise. The criterion will be based on the output wise. The every output will be executed, output value will be executed. Here is the discrimination, here is the generation. Generated image wise, the discriminator has to be applied. So this is the count of the epochs, training epochs. So epoch count, how much is done out of the 10, and how much loader value is there, how much discriminator, loss discriminator, how much loss generator. Both value will be that based on the learning rate, so learning rate wise. Then gradient value, number of gradient will be how much is there. We have to classify that. I mean, sum of that. So fake of the data's noise value and reshaping the real values of negative to still 64 batch wise. And image grid of the fake and real wise. We can add it the image real and fake image wise. One by one the steps are increased like this. So epoch 0 means starting from the 0th epoch, starting from the last discriminator last value or generator last value. The first step, they have to discriminator having the 0.7, generator having the 0.6. So once the execution process fully done, we have to do the tensor board creation. Okay, still the epoch 2, only 10 number of epochs only have to create. Here end of the epoch, so final epoch we need a less discriminator value. The last value, last D is there, right? The last D we can get the less value of the last value in discriminator. That's why we can make the proper prediction. So still the remaining epochs is there. Once the every epochs will done, so we can go the tensor board process execution. So already we was see that output, right? Steps wise how the values, I mean image has digit has to be generated. So almost done. The 7th epoch is there. Still remaining 2 only is there. So I can see the point starting the 0.7. So again the 4th epoch having contains the 1. Till it is reduced 0.8, 0.7, 0.6, till now so 0.5. So now we have to check the file manager. Here we can see the logs, because every epoch will be done means we can create the log. So inside the log folder we can see the fake and real wise individual folder will be there. So it is a fake image will be contained here, and a real thing is contains here. So now we can see that everything will be done, right? So almost done in the 9th epoch. It contains the 0.4. So we can see that discriminator last value is a 0.4, so comparatively is less, and this generator last value is 1.5, because it is not an important thing. It's not necessary to contain the values, because it generates the model just like that. The major work of the generator means they have to create the data. That's it. The discriminator only to allow the right data. So that's why we have to be expecting the less value of last value in this discriminator. So now we have to execute the tensor board. So it's an extension of tensor board launching. Based on our logs file base, they have to execute log directory in the logs file. Here you can see is a log file. Based on this wise, they have to execute it here. So is the 9th epoch, the only similar numbers only we have to see. So 9, 1, and then 7, I think, right? Or 3. So similar numbers only there. But real, it is not executed the proper way. It is collapsed. We can't see this particular output. So why? Because of we only to do the less training. So 10 epochs only we have to do. So that's why it's making this kind of generation, image generation is there. So I mean we have to reducing. Sorry. So we have to reducing the steps means we can see the fully noised. So every steps one by one we have to go. The images are generating one by one. Like the clearance will be there in one by one. So now we have to see the visible digits. How can we do that? Because already I have downloaded that log file. So here you can see the log files will be there here. So once I using this log file for our most number of training epochs. So again I have to increase in the training epochs in this place means it is take too much time. So we don't have it like that much time. So I try to the another way. They have to execution process. So using I have to open the new one, new notebook. Okay, so go with the collab. I have new notebook I have to create. In that particular notebook I have choosing the execution the zip file, and also showcase you how the data has to be clearly there. So we are using the same thing. We are using not using the different one. The same log file we have to using here. I will connect with this the GPU and I connect this. And once I entering this into, first I have to import the zip file. So manage the sessions. Okay, because my drive was I think almost full, so that's why. Okay, I have to terminate this. So now I already told you here the zip file format is there. So I have to directly extract the zip file here. So from zip file and import the zip file. Then followed by this with the extension of zip file and created to logs 1. That is our zip file name, right? Dot zip and comma. We have to read this file, so that's why I have to mentioning that, and as zip. Then followed by this zip dot extract. We have to directly extract the zip file in this particular collab. That's why this is the syntax for extracting the every zip files. So the storing data, the extracting the zip file, so storing the location like this, the content of logs. So like these names, file has to be stored. So once I run this, we can see, okay, zip file is not there. Okay, we have to installing the zip file package. I think it is not available in collab, that's why. Pip install zip file. Okay, just a minute. Maybe I have to mistake in the spelling or any syntax. Okay, once I have to check with this zip file installation. You need any syntax proper correction. You have to check with this pip install zip file. Like this, the same syntax you have to search within Google. You can get it the official page of the pip. You can see here like this. So the zip default 36 is the exact version. I have to copy this and going to execute it here. So now I run this. Oh, okay, fine, not an issue. So now the zip file will be executed. I mean installed that. Now I run this. Okay, again I have to facing the same error. Just a minute, I have to check. Okay, the spelling mistake is that's why it's executing like this. Yeah, now the error is the logs file logs1 it is not there because still I upload the file, right? So I have to upload the log file. So the zip file I have to upload. So in this particular path I have to mention it here. So once it is uploaded I have to follow the same thing. Okay, we have to wait for the completion of this file uploaded. Yeah. So it is almost done. So anyway, I have to do this. Okay, now it's done. So I have to copy the path and paste it here. And now I run this. So now it is executed. So once I refresh this file manager, we can get the logs file. Now extracted thing is there, like extracted file is there. So inside the folder, everything will be there. So now we can executing the every files is here. That means the syntax of the tensor board. Now we can copy the syntax of the tensor board. We can paste it here. So now I run this here. The launching the tensor board. Okay. So now we can see it is almost trained epoch by the 200 epochs. So then only we can see the clear vision to comparatively is this. We can see the clear vision of this fake image also, and the real image also we can see the clearest one. So now we can see the one by one. So it is a fake one, right? So it almost there's some noise and the damaged image is there. So every time we are increasing the epoch or steps, we can see the clearest one in each steps. So almost 120 after the 120, the every images will be clearly showing. So once we get done the entire epochs of the 199, we can see the almost one. So 2, 5, 7, or 4, 0, 1. So like the most of the numbers is clearly viewed. Same like as the real image we can see. So that is the accurately clearest one. Why the fake is only having the damage one? So real is every epoch starting to ending wise, the real images are clearly viewed. That is the name. So the real image means every digit, this kind of digits only is a realest one, actual numbers. So this everything is a computer generated one. That means the model generated own way, own ideas. They have to generate this kind of images. That's why in starting period they have not clearly viewed. So we can do that some process. We can almost we have to see the fake images. How much fake images is there? So like that way, we have to see the real one and the fake one. Okay, so here you can adjust the everything, so brightness and then contrast of the numbers, so like this. So whatever you can do this anything, so more of the offset or overlay, so whatever you have to do you can executing here. The smoothing of the images, so card width of the card, so how much length is needed, so whatever. So you can do this thing in your own way. So now I try to share this code with yourself. You can do this. So this is the GAN model. We have to execution the generating the MNIST digit generation. Okay. I hope everyone can understand. Okay. So now we are entering to the next one. So thank you all. Thank you everyone. Give a nice feedback. So thank you for your feedbacks. Thank you. So still it is there. So still the session is not finished. Still we have to discuss about this. So now GAN model only we have to complete right. So next one is VAE. It is a reconstructed one. So first we have to done our remaining things of OpenCV like computer vision concept. So you only see the read and write of the image. That's why you have to see, right? Then now we can continue with that. Now we are continuing with that edge reduction as well as smoothening the image. How to smoothen the image and how to detect the edge. Everything we have to see now. And the end of the next of this part, we can see the edge and gender reduction concept, the final project. We will explain and see that, and we can wind up the session. Okay. So before that, just a minute, I will. Okay, I try to connect to the comment box. So okay, can you follow to me? So I will try to share the particular the image what was that syntax, the image creation or image color conversion syntax. I have to follow to you. You can try to follow with me. Share to you. Okay, first I have to create. Just a minute. Once I check, I have access to connect with the chat box. Okay, the sign in option is not there, I think. Okay, I can't connect now. So okay, fine. So just listen. So I think of that if I share the syntax mean you can follow with me. It's easiest way to understand. But I don't have access because this is a major account. We have to execute the thing. So okay, fine. Now I explain now. So you can work with yourself. I will share this everything codes and every files I have to share you. You can work with yourself. Okay, so now we can go with that. I have to create the new file. Okay, so in this file, last time we have to do the. Okay, I have to open the same file. Why? Here we have to read and write one. So next in another file, color conversion also there. That file we have to using the grayscale, how to convert, how to create a HSV, like that thing we have to discuss. So now we can go with that edge reduction. So before that I have to freeze this. It is a multi-line comment. I mean multiple times at the same time you have to freeze. See now if I run this means in this program the write and the show the everything is not executed. That's why now I have to go with that edge deduction. Edge deduction. It is a single line command. Okay. Okay, before edge reduction we have to see with the image smoothing. First smoothing the image, then we can continue with the edge reduction. So that is the right way, right steps to understanding the concept. So that's why smoothing. So syntax already we have image, so we can directly go with the execution of the syntax. cv2 dot I am show and directly pause the particular image, that is the blurred image. Blurred image, comma, we can pass it to cv2 dot blurred. Here image, comma, 3x3. So there is a kernel size of the particular image, blurring image. So if I run this, save this, and we have to need a wait key, right? cv2 dot wait key. So now I save this. Windows. Now we have to see the original image also comparatively. That's why cv2 dot I am show original image, comma, image. So now I run this. Okay, I was never okay. Yeah, so I need another bracket for this. Okay. So now you can see it's a blurred one, it is a original one. So now you can see the difference between the original and the blurred one. Because the original image is the clearest one, but comparatively it is a little more what was that, blurred one. So we can try to see the, you can visible this, oh, sorry. So comparatively they both are different. It's the original image, it's a blurred image. It's the first one, first blurring image. So same image I have to use because Tiger already we was executing this, that's why. So next one, So same like that, there's a multiple things is there, the median blur, Gaussian blur, bilateral filter and a box filter. Like that way, the multiple blurring concept, blurring things is there. So now I have to show one by one. So first one is a blurred image. So next one you have to go the Gaussian blur. Gaussian, that means these kind of blurs only smoothing the image. So same thing, have to use this. So copy this and paste it here also. And it's a Gaussian blur. Gaussian image we have to mention. And the syntax of this, syntax of this means Gaussian. We have to represent to the Gaussian blur. Here we need to expecting this like a 0. The additional argument we have to need in this Gaussian blur, because how much image we have to pass at that time. So 0th wise we have to mention it here. So now we are trying to run this. Here we can get the 3 images: original image, blur and Gaussian blur. 3 different images we have to see. So you can see here one by one. This is the original one, it's a real one, it is a blurred one. So we can order the image like this. So you can see here. So just like that you can see means it look like a same one, but it is a different. Some difference is there. This original means it's a cleared one. Blurred means they have to blurring their eyesight. You can see the eyesight and their face features. You can notice that there was something blurred. The Gaussian blur, comparatively, it is reducing the some noises in a blurred image. So definitely you can see the difference between the Gaussian blur and blurred one and original image. So next one is a median blur. So median blur is also same like this. So I can show you the median blur, the next one of this one. Here we are going to change the name only. That's not so much different. Name and the syntax only. Median blur image. Here we can represent the median blur. Oh, sorry. Okay, the median blur is not there. Okay. Oh, the argument error is that we have to mention in the kernel size like as a single thing. So we cannot follow the same kernel. So that's why we have to, the median blur we expecting the kernel size at is a 5. So 5 is a fixed one for median blur image. So that's why. Now again run this. So now we can see median blur, blurred image and a Gaussian blur. So you will see the difference between these three: original one, blurred, Gaussian blur and median blur. So median blur will be comparatively with other images. They have to see the biggest difference between these median blur, because it's having little more blur. So that is 144 pixel way they have to execute. So in simplest way you have to try to understand. We will see the YouTube videos in one by one the format we have to change. 144, 240, 480, 560, 720. Like that way we have to increase in the quality, means that everything will be applied based on this kind of formats. So what is the major difference mean? They have to applicable for the internet connection. The internet speed wise they have to execute. So but the logical thinking wise they have to execute the logics of the execution they have to following by this median blur and Gaussian blur, blurred wise, they have to execute it every videos. Okay, this is the median blur. Next one is a bilateral filter and the box filter. There is two things only is available. So just we can execute the two at the time. So just like that, I have to passing this everything. Bilateral image. And then the syntax of this, it is a bilateral filter. I'm sorry, spelling mistake is there. Then here also we have to change in the kernel size. So the 3x3 is a kernel size. So we have to change it that. So image of this 10 to 100 is a range of the kernel, and the ending thing is a 100. I mean ending value is a 100. Same like us. The box filter, we have to follow this. Box filter image. Here the function is box filter. Then here you can follow the 0 to 7,7. That is the kernel size of this. Seven cross 7 and ending the bracket. Okay. So now I save this and run this one. Okay, here also forgot the bracket. So you can see the box filter image is too much blur, and the bilateral image is little more drawing part, and median blur other things we already know. You can see. So now I have to erase everything, just the original image and bilateral box only we have to see. I have to pass this blurred to median blurred, just like the original image, and also remaining two things only we have to see here. So now we can see box filter and the blur bilateral. So now we can see the biggest difference between the original two other two different things. So it is the smoothing image. So followed by the smoothing, we have to do the edge reduction. The edge reduction having the single reduction only is that I have to show now the edge reduction. So now I have to pass it the edge reduction. Edges is equal to cv2 dot canny of HSV. So here we need to expecting the HSV image. So HSV image we have to convert into the color. Then we have to followed by that execute and the edge reduction. So it's the range of the kernel size. So first you have to try with that normal image. I think it's getting error because we can using only grayscale or else HSV, because the both three filters will be applied, then only they have to deduct the edges. So same like that we have to drawing easily and look like a same realistic one means we can do the I think carbon paper, right? Carbon paper we have to not like a carbon. One material is there, that is a light paper is there. We can put down on the particular image means we can easily draw that particular one. So same like that here. So first we can try the original image, what kind of thing we can get. Then we have to show. So cv2 dot im show of edge. Okay, we can give it the name edge image, comma edges. save this, and before that I have to pause this everything. So now I save and run this. Yeah, it's properly detected. So you can see edges will be detected properly. So it's a original image. Original image comes from the edges only detected. So wherever some play thing is there, they have to make a drawing as a pencil sketch wise. So now we can try with the HSV format. So how to do it in HSV? So already we know the HSV, how to convert that, right? HSV is equal to CV2 dot convert color, right? I'm right in the syntax, like followed by the image, original image to CV2 dot convert color. Convert everything is caps, right? So color BGR2, which one I think, oh sorry, BGR to HSV to HSV. So now I have to show this one CV2 dot em show, and HSV image comma HSV. So same like that, here we have to change it the name image instead of HSV, because the HSV filter applied by this variables, that's why. So I save this and again I run this, we can see this. Okay, original image only is there. Okay, multiple times I have to give a CV2. Now I try this. Okay, so original image and HSV image and edge deducting. So now the comparatively original image is make an outline only. Here the HSV image, they have to try to convert the edges into so like the color shadings also they have to execute. Here the most of the places they have to enhancing, highlighting the particular place edges. So that's why there is a difference between the original into directly converting the edges and HSV into directly converting to the edges. This is the difference, common difference between the original to HSV. Okay. So these are the things we have to discuss majorly. This common. Oh, sorry. I'm really sorry. Yeah. Just a minute. Sorry for that. By mistake, the streaming scene only they have to change. Sorry for that. Yeah, sorry. It's my mistake. Sorry. So now again I run this. How many time I have to there in that particular thank you slide? I'm sorry for that. So now we can try to see this, right? So it is the original image H to HSV, and most of the time I am not see the chat also, so that's why I can't see your comments. Sorry for that. Sorry. So now you can see the original image can try to convert in the HSV trying to convert into the edge image. So is the syntax. First is the original. Here we have to read the images, and we have to show the original image. Then in the original image we have to try to convert in the HSV format. Yeah, okay, fine. Yeah, CV2.convert color. We have to try to convert in the normal image into the HSV, like the high scale visible, and the edges deduction will be there in a canny. So canny helps to deducting the edges. So once again I run to, and I will show you to you. So how just now, yeah. So now it is original one, and it is a HSV one, and it's a edge deducting one. Here I have to fixing the every sizes as the 3 cross not like a 3 cross 3 default thing. So we have to change the size. If you need, you can change that. So the syntax of figure of fixed size. Now I try to change the size. Not an issue. Image is equal to cv2 dot fixed size. So right syntax, I think. Figure of fixed size. I think it was right. We try to this. Oh, again. CV2 was now attribute figure. Yeah. So now I have to pass it to the fixed size. So try to run this. So I think the syntax was okay. Once we can check this. So I forgot this. Yeah, resize. Yeah, sorry. Yeah, like this is a resize. I forgot this. So that was a resize. Yeah, now we can try this. So now the 300 means that is like this size they have to execute. So original image, HSV, edge, and everything will be there. So now we can do execute in the everything. So like blurred image, Gaussian blur, median blur, everything we have to execute it based on the size wise, because that much size is enough to executing everything. Right. So starting with an original image, and what was that? Blurred image, and a median blur, Gaussian blur, bilateral image, box filter, HSV. Finally, it's edge reduction. So almost 8 kind of steps we have to initiate here. So now you can see one by one, we can see the difference. So now it's a cleared one. Next is a blurred image. Then going with the median blur and the Gaussian blur. So comparatively, median blur is a too much blurring that image, and Gaussian blur it's comparatively cleared. And bilateral means the without focusing the face, other places are blurred. And box filter to entirely the everything is has to be blur. And HSV means the converting the color into the color negative shades. And edge means they are detecting the edges from this HSV image. Okay, so like this way we have to create everything. So now, so like this way, these are the major important techniques we have to follow in our every place, as videos, accessing and everywhere. This kind of important things has to be followed. Okay, I hope everyone can understand this. So now I share this file, you can try with yourself and executing this. So most of the people facing most of the common errors everyone can make, like image path, first image image error. So now I have to give the tiger means this kind of image I have, so that's why I can pass it this. So if you are using this same thing means you can follow the your image. So any image you have, you can mentioning the particular image file here. Apart from CHSV, can it be BGR or RGB? Oh, you have to asking, you have to follow the BGR image, RGB to edge reduction. Okay, starting period we have to do this. So now I try this that also. So now I am not using the HSV, here I am using the same original image. So now I have to okay. So now I save and run this. Still slides, you can't visible my slides. Rajeshan, kindly check it. Okay. Sorry. It just two. Image 2. So now the original image we have to forward by the edges 2. The second edges 2 image is directly using the RGB like original image. The first edges images we can pass it, convert the HSV, then we can convert with that edge reduction. So now we can get 4 kind of images. So now we can see edges 2 is an original image. We can directly convert with that original one. Here it is a HSV. So now we can see the difference between these both. It's original directly convert to the edges, and HSV directly converting to the edges. So the major difference between these in this eyesight, because here the too much negative shades will be there. They are applicable to apply this step. I mean apply the features to here the too much noises or too much edges is there. Like that way they have to convert. They directly convert with the original image. Here they convert with the HSV image. This is the difference between the edge reduction to original to HSV. Okay, right? So now we can go into the last part of this particular FDP program of our age and gender detection. Okay, so now I have to open the particular file. So I have to close this. Now it's no needed. So now we can see it is a important thing. So CV2, the major libraries are CV2 computer vision, math is an important thing. They have to analyzing the features, the values of our face feature, and the argument pass. The arg pass is an important thing, important library. They have to detect and passing the length and the width and everything. Based on the length and width wise, they have to analyze it as a female or male, like that way they have to detect. Okay, So first function we have to highlight the face. How the YOLO and hand gesture we can create in the hand gesture concept, we can create the pipeline. We have to creating the one pipeline in our like drawing lines in our finger in my hand. So that is the important thing. YOLO object detection we have to create the frame. Same like that. First point they have to highlight the face, highlight the human face. So net of the frame they have to threshold values of 0.7. Is in the values of configuration values is there in a 0.12 still 0.10. We have to follow the 0.7 is enough for our age and gender reduction. So frame OpenCV is a DNN like direct neural network. Frame dot copy, they have to take a copy from this real time camera or image. Then you have to analyze in height and the width of the human face. It's here. Based on the direct neural network wise, they have to analyze in height and the width. Height is a 0, width is a 1. Like that way they have to represent the blob of the front image, our image. CV2 dot deep neural network, blob from image, frame OpenCV to deep neural network. The values are 300 cross 300. This is the input neurons. So input and then followed by the increasing the neurons count every layer wise. And next net dot set input of the blob and forward the passes. They have to go into the face boxes. The face boxes where they have to execute for I in range of the detection in shape 2 wise. The confidence level will be executed based on the height and the width wise. So x1, x2, y1, y2. That is x1 is reference to the width and y is represent to the height. The level of the height and width wise they have to comes to one identification of it is a gender and then have to predict the age. So rectangle frame they have to create the frame of the height and the width. Then finally is returned to the values of frame OpenCV deep neural network of the face box. Then the argument will pass based on the image wise. So parser dot add argument on the image. And the parser argument we have to follow this 4 or 8 kind of models. First one is a face model, second one is a age model, we have the third one is a gender model. First they have to detect the face, then we have followed by the detect the age, then they followed by the detect the gender. So we need a 3 kind of steps we have to initiate. That's why 3 different models will be there, major models. Proto-text file and cafe model is that needed for this. So everything I have to using the pre-trained one because it is a image related. So if we have to train our model in image based, it take too much time. That's why we are using the pre-trained model. So every models will available in the folder. Okay, where is that? Yeah. So I have to show in the folder. Here you can see. So these are all the files is there. So face detecting model, pickle file and cafe file. Gender deploying pickle file and cafe file. Everything will be cafe model file. Everything will be there. So otherwise these are all the images. So in this images wise we have to detect the particular gender and age wise. Next we have to go the model mean values. The every model's mean values. The face model's mean value is 78 and the age model's mean value is 87. Gender model's mean value is 114. That is the mean value, average mean values of every models. And then age list. So age list wise 0 to 2. So children, adult people adult means kids means they have to 0 to 2 and 4 to 6, 8 to 12, 15 to 20. Based on the face features wise, we can't predict the exact age, right? So randomly we can give you have 18 or 18 to 20 or 20 to 25. Like that way we have to predict. In real time also we can't predict the exact people's age. So like that way here model also we can create like this. So gender list is a male or female. So based on the features wise they have to predict the male is a male people or female people. Our face net is a deep neural network and read net. Based on the models wise they have to read here. First was a face model, second one is a age model, third one is a gender model. Like that way they have to predict. Here we can assigning the path of our model. Then we have to initiate the models and the reading process. Then same like that video capture. So video is equal to CV2 dot video capture as 0. So padding is a 20 paddings. So the distance between the Windows 2 system. So here it is a 10 paddings. Not like a 10, it's around 25 to 30 paddings is there. Here is a 10 paddings is there. Based on this kind of distance, we can mention it like a paddings. Then we have to create the frame and read the frame, and the result image they have to store it in the face box, inside the face box, that is highlighted the face of the human. And if they are not detecting the face, means no face detected, like that way they have to initialize. And the face boxes will create at the maximum level of the face boxes. So one like maximum 2 to 3 faces they have to predict at that time. The blob of the image reading the deep neural network, you have to execute it the one by one, the blob wise, the gender for gender net and gender list wise they have to identify. The print of the text is the gender is a male or female, like that they have to execute. Next one is the age wise. Okay, last one. So next one is the age. So age net dot set in blob wise, the prediction of age is forward by the age level. So 1 to -1, that means 1 to 4 or 4 to 6, 10 to 18, like that way they have to predict in a years wise they have to set. Finally, they executing the process cv2.put text of the result image or result frame, the gender and the age they have to execute it, and the face boxes with a 0 count, we don't know about the count, to the 10 wise we have to identify, and the font style of our text, and the kernel size of the our image, and the argument of our values of final execution, the age and gender both we will have to execute, the style of the font, and finally we can do im show, like executing the image or executing the frame. cv2.im show detecting the age and gender, the result image will be there. Okay, so first we have try with that image, then we have to go with that real-time camera. So where is the video capture? Here is that. So here the video capture already I said 0 means that is a camera, default camera. 1 means that is a additional device of the webcam. So now I have to execute in the image. First we have to go the folder. The multiple images there. So we can starting from this, there's cute boy. So I have to copy this boy's image, copy the path, and going to execute it over my place get. So inside the video capture I have to pass it the image. So no need to executing like this much path, because everything is the same folder, so that was no needed now. So kid1.jpg. So now I save this and I run this one, we can see. So you can see the detecting and age and gender. The male is a 4 to 6. The age is a 4 to 6. It is a children. It's a kid, infant boy. So as a human we can understand. So it is a boy kid. The male, that is a 4 to 6 range. So again we have to try with a different image. That was this group 2. We have to try group 2. Group 2 I have to so now the female 38 to 43. Now we can go with that next one, that is this woman. We are try woman3.jpg. okay, now we can try that woman. So now the female 48 to 53. So next this girl, or this girl, the kid girl, we have to try girl2.jpg. Now it's a female 4 to 6 age, same like that boy, 4 to 6 age. Then which one is there? So now we can try with an animals. Okay, cat.jpg try cat.jpg. So how it is what detected? no face detected, because it is not a human. That's why they have to execute no face detected. Same like that, different images. Now try with a minion. I have to try. So here also no face detected, because when the human face will be there, that only they have to detect. Other things other image we have to pass. They can't detect a particular thing. Dog also same like that. So then we don't need to execute. Now we try this man. So it is a man1.jpg, right? So now it is a male 60 to 100 years. In between the range of 60 to 100. Maybe it's a 64, 65, 70, whatever. We don't know, right? So that's why. So almost we have to do everything. So now this 1, 2 movements is there. Now try this woman 1. So 38 to 43 age. Yeah, it's happened. So still we will see these images. So now I have to ready to use my real-time camera. They have to detect my age. So now it do this video capture as a 1. So now run this. We can see. So now I run this module. So we will wait for the window. So now we can see. Yeah, so because it's a real-time one, right? So if I moving my faces means they can detect it is not properly detected. So now if I do that, say trim that my beard, so that's why they are detect the 8 to 12. They have to predict me as a 8 to 12. It's predict like I'm a small boy, like that way they have to predict. So if I look like a yeah, straight way have to see the camera, they have to predict 25 to 32. So actually I have a 22, 26 in between the range. I have my age is there. So every time I have to changing my face, they have to detect like a it's my children, like that way. 8 to 12, most of it 8 to 12. If I when I have to see my system, they have to predict the 8 to 12. So when I see the camera, they have to predict the 25 to 32, like that way they have to predict. So real time wise, if I turn any places, so real time maybe it's happening, so the more accuracy we need. Okay, so like this way it has happened. Still we was discuss about the real time wise as well as image wise. We have to discuss how to predict the image wise and age gender wise. They have to predict, like that we have to discuss. I hope everyone can understand this concept. Still today we have to discuss starting from the deep learning concepts. So activation function, loss function, and gradient booster, what was optimizers, how to we can select how they are work, like the way they have to discuss, as well as followed by the GAN model, Generative AI GAN model, how can they have to work, that kind of thing you are discussed with the example also. And before now we have to discuss what was that, the remaining image processing concept, the techniques, blurring and age reduction. So now we have to see the age and gender detection, how to detect the image wise as well as real-time camera wise, how they are accessing and detecting the faces. I hope everyone can understand this. So still we have a time, so we are entering, go with that in that remaining thing, the restructure image, like remaining VAE model. So you was discussed or not? I have to asking to you. I will give a choice to you. Still we have VAE model is there. So like this. So they have to reconstructing the one image. Look, original image same like that. It's the original image. We have to reconstructing same like that. Come on, so given anything, why everyone give us say thanks? Say yes or no, that was helps to me. If I do that means I can take this. Madana Gunasegaran sir, you please to me, yeah. Don't take the class like that way. You have to say that, say that, sir. What is the meaning of this smiley? Okay, so just like that, I have given so overall explanation. Okay, thank you for your responses. Okay, so VI is an variational autoencoders have one fundamentally unique property that separates them from the autoencoder, like varieties, that was a spelling mistake, and it is this property that makes them so useful for generative modeling. The latent space are by design continuous, allowing the easy random sampling and the interpolation. So VAE means they have to reconstructing not like only images, they have to reproducing or reconstructing the one particular data, text data or image or video, whatever. That is the major work of VAE model. So one example like this. So they have two different things, encoder and also decoder. So that was an input image. We can create this image same like this. So look like this same image, we have to reconstruct it. So with the help of the encoder to find out the encoder major work, they have to find out the features in that particular image. The decoder means they have to reassigning or rearranging the data and reconstructing the image same like as a input thing. So transformers are architecture based on attention mechanism. Introducing the attention is all you need. Foundations of modern LLMs. That is the major transformers we have to use. The familiar LLM already we know. So trained on the massive text data set. So GPT, Llama, Claude, Gemini, everything is a very familiar LLM models. So LLM thought process working like this. So what is our query base? They have to think and action and implement the answer for us. So now with this kind of thing is no needed. So just like that, what is VAE only we have to see. So now we have to go and see this. I have to open that. Yeah, now it's here. So same like that, here we have to using the torch and the numpy, so numerical Python we have to using for numerical values, and data loader same like that, we have to same here, we have to upload most of the things same format we have to follow by the MNIST digit. Previous topic you have to discuss the GAN model, the data set collection, everything is look like the same, but the process only is differ. That place we have to decide is a real or fake. Here we can reconstruct the image same like as a input. Okay, so here the matplotlib and torch vision transformers, everything is followed by the same process. Data loader, we have to get the data from the transformers, and the matplotlib help to create the frame of like the plotting frame, and optimizer is helping the Adam optimizer like that. So here first step we have to initializing the CUDA format. So CUDA or CPU, we have to check it that. Then yeah. So device is a CUDA as well as here also we are checking the transformers. So now normalize the values. Here the fashion MNIST we have to choose. We have to choosing the clothing image. Reconstructing purpose we have to use the clothing image. So I have to show how it is executed. The classes of the index in that particular one: t-shirt or a top like shirt, trousers and a pullover, dress, coat, sandal, shirt, sneaker, bag and ankle boot. There is 9 kind of classes is there. So randomly the every classes we have to reconstruct one by one. So the classes list, we can convert this one into the list format, and then the classes we have to check everything is created as a list format. And the data loader we have to upload that data set, and the batch size of 128 because it is a clothing image, that's why we have to increase in the batch size. Last part of the GAN model we have to using the 64 I think, right? Here we can increase in the batch size 128. The shuffle means randomly executed that, same like us. Here you can see the figures of the plots. So now the 10 comma 2 means 10 items in the 2 rows. That is the 10 comma 2. We have to change this one. 10 comma 5, we can try this. That is 10 items. So that's a t-shirt or top or trouser, bag, dress, t-shirt, sorry, t-shirt and a top, sandal and a trouser, pullover, bag and a shirt, everything will be there. So randomly the images are executed here. So based on the looping concept wise, they have to execute it one by one. I am show wise, they are reshaping the image. The bone are already told, that is the color map range. We have to need to change, means we can change this. And then VAE model. Here we can do VAE model, we can initiate here. So init is a major parent function, the super init is a child function. They have to support you to the major function and execute one by one input layer. First they have to entering the total neuron count is a 784. Still it is came out to the 784. So our exact input neuron size is 784. Again we can get it the output range, we can get it the same values and the same neuron count, then only we can reconstructing the particular image, right? So that's why, that's the reason of the entering and exiting values are same, and encoding the features here, and parametric what all the things is that they have to decide here. And we have to checking the CUDA or CPU wise, they have to process will be initiated here, speed or slow, like that way. They have to take a sample of this one for a rearranging format, and decode the values to assigning the every features into the same image look like. Then you initiate the forward process. Then model VAE we have to create, variation model we have to create. The model it having the architecture of this. The input linear layer contains the inside feature, input features 784. The output feature is a 400. When we have to come to the output layer, our output feature is a 784. When we have to input and output both are equal values we can get. That's why we have to fix the ready to recreate the particular image. So next we have to go to the loss function. The def loss function to the reconstructed one, and the real values only we can take. And the MSC is a mean square error loss, because it is a rearranging format. So mean square error is need to identifying the loss values. So then the optimizer is an Adam optimizer to make that process as the smoothest way. The learning rate is a 1 to 3% is a learning rate. We have to fix the score value. And here 10 epochs we have to choose. So number of epochs are 10. So each epoch is executing one by one, same process. So the epoch count will be 1, and loss values of the image and loss values of the KL divergence model, and enumerate the data loader in one by one. And image view is 0, we don't know the view about that, and executing one by one. The optimizer 0 gradient, it helps to make the smoothest way to executing the process of our model with combined with that Adam optimizer. That is the optimizer. 0 gradient also help here, and reconstructing the image like a model of our input image. So loss image values, loss KL values both are calculated by this, and finally it's adding to the value. It helps to the reverse process. Okay, now we can do the epoch starting from the 0th epoch. They have to execute it one by one. It's the 10 epochs only is there. Still it's completed the 4th epoch only. So once it is done, we can see the output. So now the epoch, ninth epoch will be there. So once it is done, we can see the output process. Ouch. So now it's done. Okay. Now we're going to the evaluation process. So we evaluated the image based on the reshaping on 28 cross 28. The array is one of the execution process of the image, some model image, like evaluate image, whatever. The model encoding we have to execute it like a numpy values. The parametric to assigning the numpy values. The decoding the values wise they have to execute it or reconstructing the image. Finally, the image will be showing into the original and the reconstructed image wise. So we can set a title like a original image and a reconstructed image will be there. So evaluated image is the original one. The output image is a reconstructed one. So if I run this, you can see this. So it's a pullover, it's the original one, it is a reconstructed one. So because I already told we can get some loss values. The loss values meaning of this, they're reflecting on like this. So again run this, there's a different one is here, the ankle boot. Also reflecting the image, like reconstructing image like this. And also original image, that's a boots. Now reconstructing to the reconstructed one, reconstructed one like this. It is a sandal, right? So sandal is make a too much loss, that's why they're not executing the reconstructed properly. Pullover also is getting some too much loss. So it's a bag, it's almost they're making the shape but it is not executing properly. So pullover almost is done. So one or two images is getting too much loss values, that's why they're not creating the proper reconstructing that particular image. So this is the VAE model of the variation and autoencoder. I hope everyone can understand this is the difference between the GAN to VAE. GAN is a to check it is a real one or fake. VAE is a to check it is a reconstructed or not. Like that way they have to execute. Yeah, day 4 we will try to share in your WhatsApp group. Day 4 attendance link we will try to share in WhatsApp group. Okay, so I hope everyone can understand. Yeah, just now I said day 4 link update we will do, give an update in the chat, WhatsApp group. Okay, I hope everyone can understand. So now we can come as usual our part. So yeah, so in this particular 5 days FDP we were discuss about the what is a starting from the AE2. So image processing, what was that, and applications, and with the examples also, multiple examples we will see. Around image processing related we have to see with that YOLO object reduction as well as hand gesture reduction. So now the agent gender reduction, this kind of 3 major projects we was discussed in this particular FDP program. I hope it was useful to you, and thank you for your supporting and attention and the responses, everything. Thank you for that. I'm really happy to this sharing my knowledge to you. Yeah, just now I said, so everyone stay calm. So day 4 attendance definitely we will share. So one still remaining 3 days, 1 or 3 days we have to already complete. Okay, so day 4 attendance only because there yesterday some technical issue, that's why we can't contain the live in this yesterday session. So that's why day 4 link we will share in a WhatsApp group. You can give it to attendance, don't worry about that. So day 5 already there in chat box. Again, check it the pinned comment, that was a day 5 last day's attendance link. So don't worry about that attendance. Okay, so now as usual entry final day we have to see with that, try to find out the logos, this logo's name. This is a familiar IDEs, so already you know IDEs. So try to find out the name of these IDEs. So every day we can wind up the session with this particular logo finding concept, so that's why. Fourth one is Python. So Python is a programming language. So what is the name of this particular Python? How we can say it? I think everything is a familiar IDs, so try to find out the answer. Yeah, both feedback and attendance both are we will try to share in a WhatsApp, your WhatsApp group. So now the final part, we have to wind up this one. Yeah, Opet Jama. First one is a PyCharm. Yeah, super. Murigation Lakshman sir. Second one is a Visual Studio. Fourth one is a IDLE. Sixth one is the Google Colab. Why is there? You can say that order in an even number. Pritham Khan. First one is a PyCharm. Fifth one is a Jupyter. Yeah, super nice answers. Opet Jama. Python IDLE is there. Yeah, Python IDLE. Yeah, right. PyCharm. That is not a PC charm, that is a PyCharm. The PC short form is a Python, P is a Python, CHS charm, that is a PyCharm. Sonal Power, PyCharm, VS Code, Eclipse, Python, Jupyter Notebook, Google Colab. Yeah, exactly. Super nice answers. Sonal Power, thank you, ma'am. Visual Studio Narayan Mutisaya, super, sir. Anand Koni, thank you, sir, thank you. Yenita, third one is a Eclipse, fourth one is a Python. So everyone said like the Python, that is a Python ideally. Why no one can notice that particular one? Integrated development learning environment, that is ideally, right? Yeah, super. So thank you, Anita, thank you. Instantly do that one, so thank you. So first one is a PyCharm. So almost every answers the Sonal Power ma'am will said. So first one is a PyCharm, second one is a Visual Studio Code, third one is a Eclipse. Yeah, exactly, Eclipse. Fourth one is a Python ideally, fifth one is a Jupyter Notebook, sixth one is a Collab, Google Collaboratory. Just now he was working in that environment. So thank you for this opportunity to share my knowledge to you. I hope everyone can understand. So if you have any doubt, you can share it over asking your queries in a WhatsApp group. We'll try to reply. And I think still 3 days materials I can already you can get, right. Still you have remaining thing day 4 and day 5 is there. So today we can wind up. Covered with the day 4 and day 5 topics. So today I will share it to the files in this last day thing. Yeah, sir, Aman Khan. So day 4 attendance we will update on WhatsApp group. So don't worry about that. So not only one people, so everyone can. Don't worry about the day 4 attendance because that is some power issue. That's why we can't conduct the session. So definitely we will share at day 4 the attendance link in your WhatsApp group. So don't worry about that. So don't miss this today's attendance. Okay, day 5 attendance already there in comment box or else in the pinned comment. So kindly check it and give it your today's attendance. Day 4 we will update on WhatsApp. Not received, Lakshmita ma'am. Already we are shared in a group, ma'am. So once again you can check with your WhatsApp group. If it not receive means again we will resend. Try to resend. Yeah, thank you, sir. Murugation Lakshman sir. Thank you so much. So thank you everyone. Thank you so much. Yeah, just now, yeah, Lakshmita ma'am, yeah. Already 1 day, 1 to 3 day session, we was shared the materials. So till 4 and 5 days only, fifth day only we have to share. Okay, so once again recheck to about the previous sessions materials and everything. So today evening you can get every day's materials and everything you can get today's evening. Okay, explainable AI is said to give an explanation. So what we have to know, So now I need to know about the particular tools names means I have to give that image or particular log the exact text wise I have to share my question to the one AI means they have to give an explanation about the tools when it was released, what is the history, this kind of thing they have to give it to me. Like that is explainable. So every details they have to give it given in an explanation way. That is explainable AI. And generate AI is to create the new things. So now I have to give it these tools. So you have to generate the logos same like this format. Like that way I have to give a prompt or command means they have to create the new logos based on this kind of types or types means or color range or style range wise they have to create the new logos. That is the difference between the generative and explainable. Generative is an create the new things based on the training data or model data wise they have to create or generate the new data. That is the generative concept. Explainable is that to give an explanation about the tool or about the product or about the text. That is the explainable difference between the generative AI and explainable AI. And also mostly explainable AI it's related to the AI agents. So now AI most of the AI tools is there like ChatGPT and Gemini. This everything is AI tools already we know. If I give on content means they have to give explanation also. That is the explainable AI. Yeah, definitely Kausalya. So definitely we will try to share everything. Thank you everyone. Thank you Amir Vani, Boyal Rahul, thank you Kausalya, thank you Boyal Rahul, thank you Lakshmita ma'am, thank you Varlakshmi, thank you Valli Mayil, yeah, thank you ma'am. Opej Jamosa, thank you, great. Shivashankar Reddy, sir, thank you. And definitely we will share the presentation and everything. So thank you all, thank you so much. If we got a chance, we will meet with another program. Yeah, Aman Khan, already I give a answer for you. So day for attendance, we will update on our your WhatsApp group. So don't worry about that. We will share it. Just wanted to ask about the previous material as something I missed during the third and fourth session. I think Amir Vani sir already we were sharing the 3 days one that is confirmed thing. Um, the remaining fourth and fifth session only we have to share. So today we will share that. Oh, evening session. Okay, ma'am. We can take it your suggestion. We will try to make it the programs in that particular schedule. How to contact? Oh, just a minute. So this is my our official contact number. My mail ID also there. So if you have any queries, you can give it a mail to me. So try to reach out to you. Okay, so thank you so much, thank you once again everyone, every faculties, thank you for your support and attention. So we will meet on the next upcoming things. Leelavati, PyCharm, VS Code, Eclipse, Python, Note, Jupyter Notebook, Collab. Yeah, super, nice try, Leelavati. Super, thank you so much. Okay, once again, thank you all. See you soon. So don't worry about that, sir. So we based on the attendance range wise, we need a 80% attendance. So one day only you have to miss, right? So that is not a big issue. So don't worry about that. So remaining days, rest of the days you have to fill your attendance, right? So don't worry about that. we will try to reconsider about this, about your query. So kindly give this message in a group also. So whatever we have to do, we will try. Yeah, okay, definitely Meena Priya. Thank you. Definitely we will try to share. Today evening or next day morning you can get every materials. So don't worry about that. Okay, thank you. Thank you so much.